Let's talk about the rectangular coordinate system and graphing. Okay, we know that we have really two axes. Okay, the x-axis, which has a 0, goes to the right in a positive direction and to the left in a negative direction. And of course the x-axis on the rectangular coordinate system is joined by the y-axis, and it gets larger as you go up and smaller, or negative if you would, as you go down. Remember that? Now, as you see, it's divided into 4 parts. The first part, or quarter, or quadrant,
I know that, dude.
we call quadrant 1, which means
I know you are, but what am I?
we're going to have a quadrant 2, a quadrant 3,
Certainly.
and a quadrant 4. Okay, so when I speak of a point being in a certain quadrant, hopefully you'll know.
Holy alphabet.
Hopefully you remember how to graph a line. The first step that I always told you to graph a line, you got it. Solve for y, and it's going to allow us to use our calculator as well. So who's keeping y from being alone? That minus 2x. So I'm going to do the opposite. Add 2x to both sides. Both sides now. He'll go away, and let's see, I'll get 3y equals 6 plus 2x. Can't add those. Now I got to get rid of the 3. He's multiplying, so I divide both sides, the opposite, by 3. And I'll get, he'll go away, and finally I'll have y by itself. Y will equal 2 plus 2/3 x, or 2x over 3. Now in a problem like this, you may remember that I told you to put in not 0, 1, and 2. You could, but it's going to make life easier if you put in multiples of the denominator. Multiples of 3 in this case, because then you'll get rid of the fraction. Let's try it. Put in 0 for x, and nicely my formula for y tells me what y is equal to. In this case, y will be 2. And I'll graph that point. Go over none and up 2. Now let's put in a 3. For x, the 3's will cancel. That's why I chose 3. And I'll get 2 plus 2, or y is 4. I'll graph the point 3, 4. Go over 3 and up 4. Now I always tell you to do a third point just to make sure. So we'll use another multiple of 3, 6. Putting it in for x. It's nicely going to cancel, isn't it? Not completely. I'll get that 2. And then do your multiplication. 2 times 2 is 4, plus another 2. In this case, y is 6 also. So I plot the pair 6, 6. And I know I'm hunky-dinky because, look, they line up.
You look marvelous.
I'm not finished yet. I have to draw the line. And that is one way that we've learned up to this point how to graph a line, to solve for y and put in 3 points. There's going to be one more. I know I'm notorious for giving you only one way, but this is the big leagues now. I'm going to want you to know another way to graph lines.
I want to tell you my secret now.
This is a nice, easy way. Once you have something in, quote, standard form, looks like this, when the y and the x are on the same side, basically, we're going to use intercepts. Remember, if you would, or consider, that when x is 0, in the middle there, in the middle here, when x is 0, that's going to be the y-intercept. That's going to be the y-axis intercept. And we love 0. 0 is easy to work with. So let's set x equal to 0. It'll cancel that term out, and we can solve for y now, and we'll get y is what? Y is 2 in this case. So I guess the y-intercept is 2. Well, you can graph the point 0, 2 and see that. Now that's the y-intercept, where x is 0. The x-intercept is going to be where y is 0. Once again, we love 0. We'll put in a 0 for y in this case, and it'll be easy to work with. That term will cancel out. And we'll solve this time for x. Dividing by -2, I get x in this case is negative 3. And if I graph the point negative 3, 0, that is the x-axis intercept, and I only need 2 points. And I've graphed that line, son of a gun. It's another way, okay, possibly to use. Okay, I'll call that the intercept method.
Thank you very much for joining us tonight. We'll see you tomorrow. Good night, everybody.
That's enough for today. We'll see you next time.